හරි. දෙන්න ලයින් අටකට. බලමු පාටිසිපන්ට් 16 තාම ඉන්නේ. 17යි. මේ මම ඒක අගවව කරන්නේ මේකට. තේරෙනවද? හොඳ පැහැදිලි කරයක් ගත්තම අගවව කරන්නේ. තේරෙනවද? මම සෙලිපෙත් දුන්නා එච්චරයි.
ඉල්ලන්නේ නැහැ. බුණානේ. බබා හෂියෝ බේසික් ස්ටැටිස්ටික් කියන එකේ තමයි ලොග් වෙන්න ඕනේ. ඔයාට ලොග් වෙන්න මේ මම ඔයාලා ලොග් කරන්නේ මම රෙකෝඩ් කරගන්නම්. හරි. අපිට මචං මේ 12 ඉඳන් මේ අනිත් එක කරන්නේ නැහැ නේ. ඔව් ඉතින් ඒක විතර එන්න ඕනේ.
Very good morning to everybody. Hope everybody can hear me loud and clear. It's very nice to meet you all. First of all, some of you need to attend to something. Well, what I want to see is that with names, at least one name, one word name, followed by the registration number. In case if you don't have the registration number, please include name followed by the NI, National Identity Card number. Can everybody change your name accordingly? Did everybody hear me? So along with your name, you need to have either your registration number or otherwise the NIC number, National Identity Card number. Can everybody get it changed, get the name changed?
Hi, sir. Good morning.
Good morning.
Sir, actually, I am an international student and I'm taking this class from my country. So what should I do about that?
Okay. Shall I tell you? Can you include some kind of number, passport number or something?
Where should I put it? What?
No, along with the name, now you can see when you log in, you have given a name.
Yes, of course.
Along with that name,
I log in with my name actually. Mahanur Nadir is my name.
That's right, I can see that. But along with that, can you include a number to be consistent? Now, bracket guest.
How do I do that?
How did you define the name here?
Okay. Yeah. I have it. 1 second. I'm gonna add, like you want me to add my passport number in this name.
Yeah.
Okay. Just give me a few minutes. Thank you.
You can go ahead then, yes. Others also, can you attend to that? Now I find Sachini as an example. Can you, Sachini, add your registration number or otherwise the NIC number? Sampath, can you attend to that? 2293 what 2293 PDN is that number correct? Somebody has specified the number as 2293. Is that correct? Ah. Xavier Wilfred, can you include your registration number, otherwise the
No, I still don't receive the registration number.
right? Can you include your NIC number?
Okay, I will.
Right. Oh, thank you. Ashan Madhusana, Ashan Madhusana, can you include your registration number, otherwise the NIC number?
Okay, sir. Okay.
Okay, thank you. Everybody ready? Yeah, I think that's enough. Those who haven't done it so far, please do that so that we can get on with the business now. Right. Hope everybody knows my name.
Yeah.
Right. So this is about me. Of course, I have a PhD in statistics. Okay. This is about me. I can see all your names, but as you know, well, our meeting mode is online, so that we cannot do any physical communication. I hope at some point we'll see each other. Right. Well, the subject that we need to deal with today, or the title of the course is Basic Statistics, which is a 2-unit course. So that, well, according to the arrangement of the course, we have 30 hours of lectures. So you can see that since everybody has received the schedule, or the timetable, we have identified 8 meetings of 4 hours or that's how we have identified. So it comes to about 32 then altogether. I think that's fine. Okay. Well, the course consists of only lectures. Well, this is supposed to be the first course in statistics. Well, I think most of you are taking part in this course. This course is compulsory to all the students across all the degree programs that you have enrolled for. The reason is that, as you know, statistics is essential, not only in the process of education or conducting research. By the way, can you all keep your mics mute, please? Right. So this knowledge, at least at the level of basic statistics, is essential. That's why we have incorporated this kind of a course for every student. The reason that we have identified it as prerequisite is in the sense that in case if somebody has gone through a similar course and then perform well, such a student is not required to follow this course theoretically. And then I suppose by now everybody has received kind of recommendation from the corresponding boards of study regarding whether specific student should follow this course or not. But I recommend, even if it is not recommended, even if it has not been recommended, please pass the message to those students just to follow this course. Well, one thing is that obviously the grade that you will get at the end will appear in the transcript. So that if you are kind of familiar with the content that we are going to address in the course, this is the first course, the basic statistics. In reality or theoretically is kind of an undergraduate level course. So those who haven't got exposure, well, you are supposed to have that exposure. That's why this course is offered. So I was telling is that even if you have performed well at an undergraduate level, and then you have not been recommended to follow this course, I recommend those students also to follow this course, and nothing to lose at all. Thing is that if you have done well in that course, and if you are thorough with or familiar with the content, you can end up with a very good grade. And the advantage is that that grade will appear in your transcript. Say, why not have a grade, an A grade in your transcript? It's going to be very attractive when the person sees that your transcript consists of, the transcript contains a lot of A's, including A for a course in statistics. So that advantage is there. So that please encourage those who have not joined today to join and then follow the course. And then one more thing is that compared to what you have got exposed to, we have a different approach to this course. You will see that today itself, you will understand. I'm not sure about what is appearing in this message because it's up to the PGIE authority. I suppose recordings will be made available. So that check with the PGIE system analysis so that you will get the necessary instructions. Maybe I will get into that at the end of the course. Okay, or at the end of today's meeting. Right. So back to the point that we were discussing. So please pass that message to all those who you know will be following a course at the PGIE. Okay. And then with respect to how the course is administered, now our today's meeting time is kind of 8 a.m. to 12 noon. And then according to the schedule, I suppose you have noticed that some days we have it 1 to 5. So I'm talking about this basic statistics course. Okay. Well, afternoon sessions, I am thinking of having it 2 to 6 instead of 1 to 5 because I have work 8 to 12 every day, or every day in sense that Saturday morning too. So that whenever space Sunday morning we have, I think Saturday afternoon we have. So shall we meet at 2 o'clock for this course, starting from coming Saturday? Okay, so instead of 1 to 5, what we have received it 1 to 5. So let's have it 2 to 6. Okay. So that morning you will have 8 to 12, and then you have a gap of 2 hours, I suppose, so you have an adequate break with that. Right. And then regarding the assessment, in general, we follow continuous assessment. In general, continuous assessment method, where you actually have 2 components. During the semester, assessment, and then end term assessment. End term assessment, it's a kind of formal examination, and then you have already received information regarding that. In fact, in that schedule, you will find on the kind of very last line information regarding the end term examination. Date is given, time is also given. Okay, so that's about end term examination. And regarding during the semester assessment, the method that we are going to adopt is quizzes. So this course, quizzes are of like just 5 minutes job. Just 5 minutes job. Well, the approach is that I just write the question on the screen. All what you have to do is to type the answer to that question and then send it to me through chat. Of course, everybody knows chatting through Zoom under this chat. Okay, if you click on that, so this is the space, this is the space to type. Okay, so that's how you need to answer to the quizzes. Okay, hope everybody understood that. I just write down the question on the screen, and then you just type the answer in that chat box and then send it to me. Okay. Only communication can be done with me. You cannot send it to everybody. Okay. So that's regarding the quizzes, and then the time allocated is usually for 5 minutes. And then when answer to quizzes, everybody need to have the video camera on. Okay. I need to see what is happening in the background. The the examination, including the final examination, when answered quizzes, as well as the final examination, is open book. You can bring your notes. Well, maybe we'll talk about that later, but the principle is it's open book, not closed book. So you can have the supporting material with you, no problem. So when answering to quizzes, no harm looking at your notes. Okay, what I want is just the answer to the question. So as you know, well, the end term examination, we will talk about the arrangement, whether you need to bring the whole note set or otherwise we'll have more efficient arrangement. We'll talk about that later on. But principle is open book. Okay, so that you don't have to memorize anything by heart. As simple as that. What I want is answer to the question. I suppose logically, when it comes to real world work, for some of you are already employed, and then the others are seeking for an employment. Once you establish with an employment, or otherwise, even without that, since you are a graduate, especially when people come to know that we have followed, well, you have followed an MSc, there will be lots of people after you asking for your service, or otherwise help. Most of the time, they have problems and they come to you asking for a solution. When providing a solution, they don't care whether you go through your notes or otherwise textbooks or internet, blah, whatever. What they want is solution to their problems. So that is the argument that we are applying, so that at least at this level, postgraduate level, undergraduate level, it's difficult to practice. Well, let's put it that way. But at least at postgraduate level, well, what we want is we need answer to real world problems. So doesn't matter what you go through, but what we want is the answer to the question. Okay, so that's why we have a policy of, otherwise, at least for this course, we have the policy of open book examination. So no harm in looking at your notes when answered to the question, or otherwise textbooks that you will have. In fact, with respect to the textbooks or supporting material, I have made one textbook for you all. Hope that will be available very soon at the PGIA. In fact, I submitted hang on. Submitted the material to PGIA quite some time ago, but it has not been processed yet. But looks like it's going to happen very soon. So when it is available, I will let you know. Okay, so that you will find the way we approach the course, or otherwise the way we discuss the content is exactly the way the material is presented in that textbook. You will find it to be like very easy to read. Okay, well, it's written in kind of day-to-day English language, so that without any difficulty, you can understand the fundamental concepts. It's titled Fundamentals of Statistics, Theory and Practice. Fact. How to implement those methods using the open source, so the free software is also given, so that later on, that is not the objective within this course, but once you complete this course, I suppose that is what you want as the next stage. So that support is also given in that book. Otherwise, in general, any textbook with the title Basic Statistics fundamentals of statistics, maybe elementary statistics would do. Okay, such a book you will find it to be like useful. These days, as you know, plenty of information is there in internet also, but one thing is that you need to be careful, with the understanding of what we discussed, try to read them. Sometimes you find that misleading information is also present in the internet. Right. That's about the textbooks, as well as earlier I was talking about the approach of assessment. Okay. And then allocation of marks for the continuous part or otherwise quizzes, you will have 40%. And then for the end term, you will have 60%. So it's very important you attend to quizzes because you are talking about 40%.
ඇයි හදිසියද?
Okay.
ඔය ඕනේ දන්න ඕනද? කට් උනා.
Can everybody keep the mics muted, please? Check and see whether your mic is muted. Right. If you happen to be absent for a quiz, you will have 0. Don't submit medicals. And the other thing is that quizzes are unannounced, but obviously you can see that it's 5 minutes job. If it is a 5 minutes job, no point informing it in 2 weeks. In 2 weeks advance, but it doesn't make sense. So quizzes are unannounced. If you happen to be absent, you will have 0. So since it is possible, you miss kind of one quiz once in a way. To compensate that, let's have at least one quiz per day, per meeting. At least one quiz per meeting, so that weightage per quiz will be like say just 5 marks out of altogether 100. So since we have 8 meetings, theoretically it will be then 5 marks each if we have just one quiz. I said at least one quiz. Might find sometime not a single quiz, and then might find sometime more than one quiz a day. So on average, let's try to have at least one quiz per day. Okay, right. So that's the arrangement. And you will find quiz is a simple job. It's a matter of continuation of the discussion we are having. So as simple as that. In fact, it's kind of a strategy using which both parties will have an understanding about what is going on. As a participant, you will have an understanding about whether you are doing okay. I will also have an understanding about, well, how far you understand what I try to convey. So it's like two-way process. And then if you find that you don't get the correct answer, or otherwise the full mark for a quiz, in the sense that you are not doing in the right direction, so you need to change the strategy. Probably get hold of a person who is doing well, find out how that person approaches to this, and then get into the correct track. It's very important. Okay. So on my side, just to complete the discussion, sense that if everybody is getting kind of not very good marks, mean something wrong with my approach, so that I also need to change my approach. So you can see that it's a two-way process. Otherwise, imagine we have only one examination and we will have it at the end of the the course. So by the time we realize those limitations, well, the time is over, the bus is gone. So that's why it's good that we have this kind of a process. Okay, so that's about the assessment. With that, I think we can get into business. First of all, why do we need statistics? Why do we need statistics? Let me take a simple example from a real world situation so that you can understand what is meant for, otherwise the usefulness. Just think of, we are in a need of comparing two sets of students. Class A and then others, group A and then group B. Suppose we want to compare the performance of these two groups. We need to compare the performance. What is the usual approach of comparing the performance? You need to conduct an examination, isn't it? Get the marks, and then based on marks only, we usually do the comparison. Suppose we thought of conducting examination, fix a date for an examination, we announce the examination, and then let's say on a particular day, we conduct the examination. Suppose in each class we have 100 students. Okay, 100 students. But as you know, on any given day, you don't find all 100. I'm talking about real world situation. Not just the theoretical situation, but real world situation. I mean, any day you find that everybody is not present. Sometimes maybe 97 is present, or that's 95 is present. Likewise, that's how you find. Everybody, you will never find, otherwise. Very rarely we find 100 out of 100 is present. With 100, some are missing. So that we will have something like, let's say, 95 here, and then maybe 94 there. And then what we usually do is that once you have the marks of this 95, you convert this into a single value, sake of convenience, and then you compare these two and try to talk about the performance of two groups, isn't it? Imagine instead of that particular day I identified for the examination, I thought of conducting that on some other day. Then the issue is that on the first day, I said that 95 students were around. Now, the other day, how do you have it? Maybe 94 from this group and different 94. In the sense that some of those who were absent on the first day are present today, and some of those who were present on the first day are absent in the second day. That's how we have it. So now those who are taking part in the examination is different from first day to the second day. So imagine we conducted the examination on the first day, and then we found that A is better than B, group A is better than group B. a person in the group B could argue of the form, say, some of our good students were absent on that day. If they were also present on that day, our group would have been better than the other group. See? Can easily make that kind of an argument. If that is the case, as you can see, there is no way we can have that kind of examination, because we will never ever have everybody to be present in the class. So how can we make comparison then? There's no way we can have a comparison. This is where we need statistics. This kind of situation can be handled only using statistics. Because at the end, we need to make a decision on which group is better than the other. So that was our objective. And as you can see that, well, we did not have the complete information. We did not have the complete information. But we need to take a decision. This is where we need statistics. Without using statistics, you will never be able to have a scientific conclusion. Scientific conclusion. So whenever you are aiming at a scientific conclusion, you have to have statistic use. Not only in assessment, not only in conducting research. Obviously, in research, well, at the end, what is expected is that you come up to the finding, and the finding is so useful, everybody start using and getting benefited. Isn't it? That is what is expected. So, in order to have that to take place, first of all, people should believe in what you say or you are finding. How do you assure that people believe your findings? This is where you have to make your conclusion scientifically. When you make scientific conclusions, only those conclusions become valid. So in order to make scientific conclusion, you have to have statistic use. Based on the outcome of after using statistics, only you should make conclusion. Only such conclusions are scientifically valid. Okay, right. Not only conducting research. Sometimes, suppose you have come across those who are involved in well, business. I'm talking about like well-established business. In conversation, they tend to say that they invested quite a lot on machine, and they were lucky that that machine works as the way the person expected, and thereby they could make good profits. You see, person used the word lucky. The person was lucky. That person found that machine to be working beautifully. But the thing is, you don't depend on luck. Instead, you can depend on statistics. I suppose you will get exposed to those things also within this course itself. So using statistics, you can find out what is the chance of being successful, what is the chance of being unsuccessful. Then you can decide whether to buy that machine or not. So you don't need to depend on luck. See? So that you will find statistic is a decision-making tool as well. Use statistics and then make decisions. Thereby minimize chance of making mistakes. And thereby now you find the usefulness of statistics. So how this subject is important. And I suppose now you can couple this with why this kind of a course is introduced to all the students across different degree programs. But it's essential. It's not exactly something to do with the subject, but it's day-to-day living. I mean, decision making, you need to do it. I mean, you need to do whatever you do. So nothing to do with the subject under which you follow MSc. Okay, right. With that, let's get exposed to the definition of the term statistics. It is defined as collection of data analysis and then making inference. I suppose except the third one, others are kind of day-to-day words that we use. Collection of data, well, can understand. Analysis also, anyone can understand. Making inference, probably inference, it's a word not that familiar with, but for the moment, let's go by like making conclusions for the moment. Okay, see, I haven't used the word conclusion here. What I have used is the inference. But what I said is that for the moment, as a close word, you can go by conclusion, making conclusions. Right. Let's discuss each of these one by one. Collection of data. Why do we need to collect data? Isn't it? First of all, why? Why do we need to collect data? Imagine we are interested in heights of students in this group. Now see, we have 148. Suppose we are interested in height of the students in this group. 148 students are there. Can I pick from, I can see the list. Well, from the list, well, can I pick one and then ask the height of that person and then use that value as the value for the whole group? Will everybody accept that? No, I don't think so. Why? I'm sure everybody's answer is that height is not the height of everybody. Isn't it? Height varies from student to student. So if that is the case, using a value of one student is not fair. First of all, forget about correct or wrong. It's not fair. Because height varies from person to person. Exactly. Height varies from person to person. Now remember the very first situation that I considered in order to show the importance of statistics. Comparing two groups of students. Within one group, do all students have the same mark? No. Listen. Within the group also you find that we have differences in marks. And our objective is to compare the difference between the two groups. And within the group also we find differences. See? Now, present example, height 148. I bet that all 148 values are different. Especially for a quantity such as height, I don't think you will ever come across two values to be exactly the same. Now, similar example, or otherwise in the same example, sometimes we say that, okay, look, well, we two are the same height. Sometimes we make that kind of statement. See, we two are the same height. And then if I ask, how did they measure the height? They might easily say that meter ruler, foot ruler, something like that, using the, or the tape, using that, they measure the height. Now let's say 168.5 two students. 168.5 or that's 168. Right. Now I ask you to use vernier caliper and then measure the height. Then you will find two values to be different. Well, earlier using the tape, you said that both values are, the two values are same. But now, after using a vernier caliper, you find that two values to be different. In the first case, what happened was that the instrument that we were using to measure the height is not sensitive enough to detect the difference. That was the problem. Not that the height values are same. Similarly, these days, say, suppose you want some sugar, say there is no sugar. So where do you go? You go to a place, say supermarket, and then well, these days when you walk in, you can see sugar is nicely packaged and labeled also. What you have to do is to pick one and then take it to the counter, you pay and take it to your place. The nice label also 1 kilogram, and then if you want, you can ask them to measure it for you, and then they will measure it, and then you will see it's 1.000. That's fine. If you take two packets, each one you will see 1.000, 1.000. But you take it to, suppose you are working in a place, where conduct maybe more serious weighing. In a lab, if you use a scale and then measure the weight, then you will see it's like 1.0006, something like that. So looks like, you have got more sugar compared to the price that you paid at the supermarket. You paid for 1 kilogram, but you have got more than 1 kilogram of sugar. Can you believe that? Maybe other way around as well. 0.9994. Something like that. You paid for 1 kilogram, but you haven't got 1 kilogram. By the way, at the supermarket, you found both those packets weigh 1 kilogram each. But now after coming to the lab, you find one is bit more than 1 kilogram and the other one is bit less than 1 kilogram. See, what happened was not that the two weights are exactly the same or the amount of mass present is exactly the same. What happened is that at the supermarket, the instrument, the scale that they were using is not sensitive enough to detect the difference. That's what I said. You never have two values to be exactly the same for a quantity such as height and weight. Right. Back to the issue. We are interested in height of students. Now we find that one is not enough. One value is not enough. Why? Height varies from person to person. So it's very clear. In order to have an understanding about the height of students, we need to have at least several values. No, we have already said that one is not enough. Meaning what? We need at least several values. What do you mean by at least several values? There is a need to collect data. Unless you collect, how can you have several values? You say you use the word collect. We are talking about general collect data and then there are at least several values. One is not enough. Okay, so that there is a need to collect data. Say collect data mean not one. One is not enough. We are talking about at least several values. So what was the reason? Is that we find values being varied. Values being varied is the reason. The phenomena of values being varied, this phenomena of values being varied, this phenomenon is called variability. Variability. And such a quantity that varies from one observation to another quantity that varies from one observation to another is called variable. Such a quantity is called variable. Variability and a quantity is called variable. So now you can link the very first situation I expose you all to. That, remember I said that time, in order to tackle the situation, you need to have statistics use. I think now you understand the principle behind that. It's because of what? It is because of variability. In fact, because of the phenomena variability, we have a subject called statistics. Unless there was variability, there wouldn't have been a subject called statistics. So variability can be tackled. You see, in the presence of this variability, we have to take decisions. If there is no variability, it's not that difficult to make decisions. In the presence of variability, if you want to make decisions, you need to have statistic use. What is the opposite of variable? In the sense that now variable is a quantity where the value varies from one observation to another. Now opposite is what? Value does not vary. Every time you find value to be same. How do you call such a quantity? quantity that does not vary from one observation to another is called, as you are familiar with, is constant. It's constant. Variable, give examples as what? Height, weight, say blood pressure, isn't it? Yield from a crop, amount of milk that you get from a cow, isn't it? All those are variables. Now, opposite of that, just a minute. Just now I got a message from the computer system analysis computer unit is that some of you have not actually adhered to what I said. In the sense that, remember I said you need to have a name along with your registration number. If not, the national identity card number. Say as an example, Wyoming. Can you add your registration number? Or if you don't have that, can you add your NIC number? Because the thing is that later on, the main issue is that when it comes to submitting those quizzes, ultimately we cannot match your quiz marks with your end-term examination marks. So that problem is there. So that's why from the beginning, we need to have, that matter sorted out. Okay. Sometimes we find it's very difficult to release marks because we cannot identify the quiz marks of some students because the name that they use in the end-term examination is not the name that they have used for quizzes. Quizzes you join online. So we find that, the names appear in various different ways. Sometimes machine to machine, different machines are used. So that different name. So as an Isanka. Isanka, can you attend to that? Isanka Harushani.
Yes, sir.
Okay. Can you now your name? I think you understood what I said. Say, Sanka, you have just the name Sanka Harshani. Along with that, can you add your registration number? If you don't have a registration number, can you add the NIC number?
Okay, sir.
Okay, please. So those who haven't done that so far, please do that. Okay, right. Right. So dealing with constant. Example. Say atomic weight. Density of water at a given temperature. Maybe number of chromosomes. In a cell of a particular species. I mean, they are fixed values, isn't it? So if I want to know density of water at a specific temperature, density at a specific temperature, do I have to ask many students to measure the density? No, no need. If a student knows how to measure the density, as well as the person can do it without making any errors, one person measuring is more than enough. Asking density to be measured for several students is wasting resources. Isn't it? Why? Because everybody should end up with exactly the same value. That value cannot vary. Second, okay. Carmelita, can you please add your registration number to your name? Carmelita, I hope I'm pronouncing your name correctly. I'm sorry about that. As I have been telling, please add the registration number to your name. As Carmelita left or something. Anyway, okay. Right. Is that clear? Right. So if you are dealing with a constant, as you can see, one measurement is enough. One observation is enough. Thereby, we can take a decision. We can have an idea about the value. But if it is a variable, we can see that with one observation, there is no way we can have an understanding about that quantity. Now, if you really think about it, an example like by the way, please keep your mics muted. Include it into the name list. Don't send a text. Okay, so in the as the way your name appears in the Zoom registration, include this number also along with the name. Okay. Right. I think first day, we have these challenges also. Right. I said, if you think of real world situations such as, say, sugar requirement, we know some like much sugar, some don't like sugar at all, some like, less sugar. That's how we find the sugar requirement for different individuals. As a country, we need to know the sugar requirement because, well, in Sri Lanka, we don't produce sufficient sugar within the country. So we import sugar. So import, we need to know how much of sugar to be imported. As a country, when you say amount to be imported, you are talking about one value. But for each person, we know the requirement varies. We are dealing with the variable, but see, we need to take a decision. We need to take decisions. But we are dealing with variables. Okay. So this is the challenge. Dealing with variables where we get exposed to variability. And then using statistical tools, making decisions is termed as statistical thinking. Everybody should develop this statistical thinking. Need to understand there is something called variability. Not to get disappointed or not to get like overwhelmed. Okay. Today you have got a value, but tomorrow you will find the value to be different. Need to have that statistical thinking. And then using statistical tools, statistical methods, taking decision is altogether is these days referred to as statistical thinking. So this is what everybody should develop. Have an understanding about this statistical thinking. Now, dealing with variability. Right. How do you find this variability in nature? If I ask a question from ask a question individually, would you like variability? I'm sure everybody will say yes. Otherwise, imagine eating the same food item every day for every meal. Can you believe that? I don't think we can tolerate that. So now you can see that when you think in that terms, I suppose now you can understand how important this variability is, isn't it? So this variability has to be retained, isn't it? Otherwise, this life is going to be utter boring. And then imagine everybody looks exactly alike. Would it be interesting? I don't think so. Can you think of a place where there is no variability? Well, I think kind of imaginary situation, as in through religions, everybody has got exposed to, exposed in the sense that everybody has come across kind of a definition called heaven, isn't it? How does it define? It's like where you find everything at extreme. Beauty, extremely beautiful. Food, extremely tasty, isn't it? That's how it is defined. That's why everybody is kind of, I said, aiming at going over there, isn't it? What we say is that after the death, we'll be going there. Anyway, now, if you think about that bit more carefully, now what I said is that beauty, extremely beautiful. And imagine two individuals are there. And then if a question is asked, which person is more beautiful, if we can identify one person to be more beautiful mean, at least by argument, other person with respect to beauty is not that extreme. Is it? If you can find one person to be better in sense that, then at least one person is not that extreme with respect to beauty. So can that happen then? No, initially what I said is that everything at extreme. If everything at extreme, then both should look exactly alike. Isn't it? And then extremely tasty. Extremely tasty. But if two food items are there, if I ask which one is better, if you can say one is better in sense that at least one is not at extreme. And it is contradictory. Because earlier what he said is everything at extreme. So that we should be having only one food item. Because if two food items are there, obviously you will find two different tastes. Two different tastes, and then you will definitely say one is better than the other. If we want to say that both are exactly the same, then it has to be the same food item. Meaning what? Everybody looks alike. Every time you are eating exactly the same thing, is it? Will that be interesting? I don't want to talk anymore because it could be sensitive issue. But good old days, Bernard Shaw, I think one of the famous writer, said that that person prefers to go to hell rather than going to heaven after the death. Person said, the reason is hell, you find variability. You find variability, whereas in heaven, you don't find variability, otherwise at least less variability is there. See? You see, go to hell instead of going to heaven because of what? Variability. Now, I mean, that shows how important this variability is. Variability is the driving force. Unless there is this variability, you cannot see this kind of dynamism, or otherwise, the movement in the world. Everybody is attending to different activities, blah, 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 because everything is different. See, variability is there. Right. Now, let's look at nature. Let's consider two situations. One is the forest, natural forest. Let's say like Singaraj forest. Other one is paddy field. Forest and paddy field. Forest, natural forest. Have you ever heard about people applying fertilizer to natural forest? No. Applying pesticides to natural forest? No. Applying water to natural forest? No. And then cleaning the place? No, nothing like that. Nothing is there. But paddy field, now it has become so intensive. If you happen to ignore the place, at least for one day, it's kind of, you can forget about the whole problem. It has become so intensive. First day, you need to apply chemical number 1. Second day, you need to apply chemical number 2. Third day, you need to attend to certain activity. Like so many different activities are there. But it was serially listed, one after the other. And now if I ask a question, when you think of the two systems, which system is more stable, forest or the paddy field? I'm sure everybody's answer is what? See, you don't need no interference, no intervention is required for forest. Forest is doing very well unless we go and fell the forest. Forest is more stable compared to paddy field. What is the reason? Well, forest, you find very high variability. Very high variability you find in the forest. Whereas in paddy field, we find variability. Hardly any variability. Why? How many species do we expect in the paddy field? We expect only one. We destroy all the other. Isn't it? By applying chemicals, different material, what we try to do is to get rid of all the other. We want to see only paddy plants, one species. So you can see that very less variability is there in the paddy field. Because of that, it has become so unstable. That's why I said that if the attention is lost even for one day, forget about the whole crop. So unstable. Reason is what? It's unstable. But forest, very stable. So that you can see, in reality, higher the variability, increases the stability. That is the reality. That is how we find it in nature. This is where we need to preserve this variability. We are talking about different types of variability. For instance, these days we talk about biodiversity. It's a hot topic. Biodiversity. We say Sri Lanka is high biodiversity hotspot. That's how they say it. Isn't it? So see the importance of biodiversity. Or if no diversity is there, as you can see, life becomes very boring, isn't it? And not only that, we find that we become very unstable. That is the reality. So we need to maintain. Sometimes as humans, humans are famous for going against nature, isn't it? See, sometimes we have attitudes that we don't need variability. Isn't it? I think you know what I mean. See, some time back, in Sri Lanka, we had a very serious problem. And that problem went on for several decades. Well, in a way, you really think about it, it's like, we did not kind of appreciate the variability. Because main reason humans, we go against nature. Right, so that's about the variability. So it's all because of variability, we need the subject statistics. Right. Handling variability using statistics. That's what we said. Right. Back to the point, in the sense, back to that same example. Having an understanding about height. Now what we said is, we need to have collection of data, or that we need to have several values. So now the question is that, how do we collect data? Imagine you were physically around, and then in a classroom, well, usual, traditional classroom, you find it to be like, you find row of chairs, maybe with a set of desks, like that's how you find. And then imagine in such a situation, I thought of collecting height values of the first 10 students. First 10 students. Or maybe before getting into that, suppose in the class, let's say 50 students are there in the class. And then again, what I'm interested in is height. Okay. And remember, the way I said this is that with marks also, after having marks, I convert those values into a single value. Why? Because it is easy to work with. Single value, it's easy to work with. I'm using the word single value for the moment. Okay, just for the convenience. So, in this class, where we have 50 students, suppose I'm aiming at true value. Did you hear me clearly? True, otherwise correct value. Correct value. What do you mean by that? Imagine I ask every student in the class to find this value. By this value, I said after having all the height values, converting that into a single value. Suppose I ask every student to undertake that as a study. And then if I want every student to end up with exactly the same value, that is what is called true value or the correct value. And in that case, how many values each student should get? Hope everybody understood the question. I want every student to undertake this as a study. And then I want everybody to end up with exactly the same value, which is the true value or the correct value. If that is the case, how many measurements each student should take? How many measurements should each student take? I suppose everybody will say each student take measurements of everybody. Or should take measurements of all students. Measurements of all students. First student is also taking all the measurements and then convert that into a value. And then second student is also taking all the measurements, convert that into that single value using the same method. And then you will find everybody is ending up with exactly the same value. Instead, if the first student is using 40 students, second student is also using not all the students, let's say 45 students, where the 40 students, even if the number is 40, first student is having 40 students different from the second student is having the 40 students. So that two students will end up with two different values. If everybody wants to end up with exactly the same value, then everybody should study all the students in the class. Collection of all the units is defined as or the termed as by the way, I got one more message from the PGIA system analysis that still about 369 students have not include that number in the name. So can you attend to that, please? Devni Ekanayaka is one. Likewise. So those who have not included the number, can you please attend to that? And it's important, the Chanuka. Chanuka, can you include that number? Can you include your number? Hope Chanuka heard me. Chanuka, are you around? And one more thing I want is that everybody to be around. Sometimes we find that students log in and then
Yes, sir.
various. Okay, Chanuka, can you include your number also, registration number, or otherwise the identity card number?
Okay, sir, I will.
Along with the number. Okay, thanks, Chanuka. Yeah, likewise. Yeah, Devni has done that now. Ishanka, I think I told you earlier also. Isanka Harshani. Isanka,
Yeah, yes, sir.
can you include your registration number also along with your name? Can you edit the name here appearing on the screen now? See, you are as in the list of participants. Can you attend to that, Isanka?
Yes, sir. I haven't received numbers, sir.
No, that's fine. Can you include your identity card number, NIC number?
I include the NIC numbers, sir.
But I don't see, it is not appearing here. Where is now your name? Is it at the very top now? Now see, can you see your name on the screen? With the arrow pointer? Are you looking at the screen now?
Yes, sir.
Okay, now you see, Isanka Harsani, your number is not there, only the guest is there. So instead of guest, can you include your national ID card number?
I include the ID numbers, sir.
Now, if you include that, it should appear here. Now, see, with others, that number is there. Just edit this name, include that number also. Sankar, did you understand?
Yes, sir.
Okay. Right, those who haven't done that yet, please attend to that. Now, Isanka has to do that, Chanuka has to do that. Likewise, I think they have passed me a list where 7 students haven't done that. Yeah, Harshani, please include that in that name list. Sending a text is okay, but you need to do that at that particular place, because then only when you submit message, that name get included in that the text message. Otherwise, well, it appears only by whatever the name appears in this list. Now, Kavindi, no. What happened to Kavindi? Okay, right. I think, okay. Prasadi. Prasadi is okay. 2351, that's fine. That will be wasting our time, isn't it? Rashmi, can you hear me? Right, so this is the other issue. Sometimes students log in, and after that, they attend to various other activities, including shopping. Sometimes I find that when contact the students, if they happen to respond, they say that they are at supermarket or somewhere, so cannot answer to a question. Sometimes I ask questions, and then they are not around, logged in, but can't even hear what I say. I mean, not even with the phone logged in, and then the computer is at home, then the person is at the supermarket. We don't want that to happen. Okay. Later, if I find that, I will remove those names from the list. Okay. Now, I hope everybody knows that. In case if I remove, that person cannot log in again. Right. Now see, Rashmi is not responding. See, it looks like Rashmi is not around. Okay, so this is the first day. It's good that first we get the message. After that, we will implement those starting from the second meeting. Okay, right. Maybe we will have a quiz at the latter part so that we will have more understanding about what has happened with what names. I haven't got the numbers. Likewise. Right. Shall we move on? Collection of all the units is defined as population. That is what is termed as population. Collection of all the units. Let me add the specific word. Under study. Every time it doesn't mean population of a country. Okay. So in the class, if only 50 students have enrolled, so the size of the population is 50. That's all. What I said is that I'm interested in heights of students in that class. Not everybody on this whole earth. If only 50 students are there, then I'm talking about 50 units. 50 students. Okay. Right. So, now back to what we said immediately before, is that if we want the true value or the correct value, then we need to study the whole population. If we study the whole population only, we can have the correct value of the true value. In fact, we are interested in what is happening in the population. I said the height value of the whole class, not some of the students. I said the whole class. Right. But the thing is that sometimes we find population to be very large. Imagine instead of the class, I'm interested in height of all Sri Lankans. Then I'm talking about 22 million. 22 million. If you undertake that study, you can start, but your grandchildren will complete the report, isn't it? Measuring 22 million, yeah, unless you use very efficient method, you won't be able to get the value, isn't it? Sometimes you find population to be so large, studying the whole population is not practical. Then the question is that, how do you tackle the situation? Now we can't study the whole population. So what is the way out? Let's say this is the whole population. Now population is so large, we cannot study. Okay. So the only possibility is study only fraction of that. Only a fraction of the population, which is called a sample. So what is a sample? Sample is a fraction of a population. So sample is just a fraction. Obviously, can we get the true value or the population value from the sample? No way. No way. Why? Because you have studied only part of the population. And then for the moment then, characteristic value. I use the word characteristic in this case. Not one of the observations. Now remember I was talking about kind of converting them into a single value likewise. That is what I am referred to here by the term characteristic. Characteristic value in the population is called parameter. So this is the value that we are interested in. Now remember earlier I said that the height of students of that 50. That value is called value from the whole set. Value from all the students is what is called the parameter. And remember I was telling every student will end up with exactly the same value. Meaning what? Given the population, parameter is a constant. Mind you, given the population. If it is a different population, that height value is different. Given the population, that value is a constant. So parameter is a constant. It is a constant given the population. Okay. All right. Now, corresponding value. Now, said characteristic value in the population is called parameter. That is what we are interested in. But the thing is that very often we cannot get that value. Why? If you want to get that value, we have to study the whole population. But studying the whole population is not usually practicable. Usual. But sometimes you find it to be like practicable. Suppose in a situation like, say, fish in a small pond. Small pond. If you really want to, you can empty the pond and then get hold of all the fish. And then maybe, well, kind of social study, studying all the banks in Sri Lanka. All the banks, not bank branches, all the banks, I said. How many different banks are there in Sri Lanka? Maybe about maximum 25. Like Bank of Ceylon, People's Bank, they say Commercial Bank, likewise, different banks are there. How many different? Maybe about 25. Yeah, 30, 35, likewise. That's all. That's all. You visit the head office of each bank and get the relevant information. So it's a matter of talking to 35 or 25 individuals. Maybe you get hold of chairman of each place, get the necessary information. So that is your population. Only 25 units. Is it large? No, so I suppose you don't want to call that as large. Only 25 compared to 22 million. See, sometimes you find population to be small, so you can deal with the whole population. If we are dealing with the whole population, we are talking about a constant. Isn't it? Then you are talking about a constant. But if studying the whole population is not practicable, then you find it is a challenge. This is where we need to study a sample. With the sample, what can you say about that corresponding value? That value varies from sample to sample. Isn't it? That value varies from sample to sample. Okay. So sample value is not a constant, but somehow that value, corresponding value from the sample, I mean, talking about characteristic value, corresponding value from the sample is called estimate, or sometimes called statistic. Oops. Estimate for the statistic. So when you hear the word estimate, you immediately understand estimate is different from the true value. Isn't it? Estimate is different from the true value. Right. And the idea of an estimate is that from that you get some understanding about the true value. What is expected is that the estimate to be close to the true value. That is what is expected. Okay, right. Now, to have the continuity, remember what we said is that there's a requirement to collect the data. Now we are talking about how to collect the data. Now, we have come across something called, now we see, we collect the data by means of a sample. Right? So now you can understand. We collect the data by means of a sample. So now the question is that, begin this sample. See, from the sample, what we will have? We will have an estimate. And what is it for? With that, we can have an understanding about the parameter. That is what we are interested in. Now recall something I said. Sample, you take it to be the first 10 students sitting in the class. It's pretty convenient, you know. So usually the resource person is sitting in front, or the academic member is sitting in front, so that the closest students are the students sitting in the first row. So suppose 10 students are there, and taking that as a sample. How about that? And then having the estimate from that 10. Now, one thing we have cleared. Is it only one? No. 10 students are there. I said, 10 students are there in the first row. Right. What can you say about that estimate? The point here is, imagine I make this as an announcement. I said, following week or the next week, I will be picking the first 10 students, or the 10 students sitting in the first row as my sample to study height. Just imagine. So then if you want, you all can get together and then ask you can ask, get together and then ask tallest 10 students to sit in the first row. Tallest 10 students to sit in the first row. Now, if we have those 10 as my sample, what can you say about the value coming from that sample compared to the true value? Will it be larger than the true value, smaller than the true value, or that is more or less same as the true value? I suppose everybody will say it's higher than the true value. How do you call such a value? Well, we said that value that we get from sample is called an estimate. So that very often we say it is an overestimate. Overestimate. Similarly, if it happens that the, let's say, shortest 10 students sat in the first row, or the short students sit in the first row, then it will be opposite of that is underestimate. Underestimate. Specifically in this case, see, you all got together and then decided the tallest 10 students to sit in the first row. So it's a kind of manipulated value, isn't it? Manipulated value. How do you call such a value in day-to-day life? Bias. That's it. Such estimates are biased estimates. So you can see if the estimate is biased, you find it to be what? Either an overestimate or otherwise an underestimate. So what we want is then an unbiased estimate. Sorry. What we want is an unbiased estimate. With an unbiased estimate, we expect the difference between estimate and then the true value parameter, value of the parameter. This difference to be small. So now the question is, how do you pick the sample in such a way that we can assure our estimate is a good estimate, or otherwise an unbiased estimate? Right. Now, if you want the sample values to be close to the true value, you can understand that, say, having the tallest 10, what is the issue with, that such a group, one was tallest 10, what is the problem with that? Now imagine your group need to get something sorted out. Say you have a concern as a group. Let's say at least some students have a concern, so that you all thought of getting that sorted. So that who do you have to talk to? Yeah, you will have to ultimately talk to the director, and the PGI director. In such a process, what do you all do? Since everybody has gone through the first degree, I think you know how to handle such a situation. Do you think you all need to go and meet the director? No. What do you usually do? You send one person. How do you call such a person? Representative, isn't it? Representative. Now you see, represent. Everybody doesn't need to go and meet the director. 1 or 2 and meet the director and then pass the message then. And what is happening is that that person or otherwise those two, will they talk about what those two want or what that person want? No. That person will convey the message of the whole group. Maybe that person himself or herself doesn't like with that idea, the ultimate idea. But still, that person cannot convey that person's personal idea. That person should convey ultimately the decision made by the class. Maybe from the majority of the students. Isn't it? So that everybody doesn't have to go there. Representative going there is enough. Likewise, if we can have that sample to be a representative of the population, then we can make this difference to be small. So what we want is, in order to have an unbiased estimate, we need to have what? Representative sample. How do you get a representative sample? Representative sample in the sense that we should give the opportunity such that any student can be in the sample. Obviously, everybody cannot be in sample, but any student can be in sample. If we say only the tallest student, can anybody be in sample? No, you cannot. See, that's why we cannot call such a sample to be representative. That's why we cannot call such a sample to be a representative sample. If it is representative, anybody should be able to get included into the sample. And the technical term that we use for that is providing anybody can be in the sample is called random sample. So random in sense every unit in the population has an equal chance being selected into the sample. Every unit in the population has an equal chance of being selected into the sample. That is what is called random. Okay. I suppose everybody is kind of familiar with picking a random sample. You know what is meant by a random sample. So, methods. 1 out of 2. If you want to pick 1 out of 2, easiest is what? Toss a coin. Isn't it? Tossing a coin. Now you see, which team is going to start? Isn't it? How do we decide? 2 teams are there. We need to select 1 out of the 2. So what do we do? Toss a coin. Selecting 1 out of 2. But selecting several out of a substantial number, can we toss a coin? No. By tossing a coin, can we decide? No, we cannot. So that second approach is what? Drawing numbers. Okay. What do you mean drawing numbers? Suppose we have 50 students, you write down numbers 1, 2, 3, up to 50 on 50 pieces of paper. 50 pieces of paper. And put it into a box. Put it into a box. And then mix them well. Take one by one until we satisfy the number. Do we have any idea which number is going to come up first? No, no idea. And then all 50 are there, so that equal chance is there. Equal chance is there. Then all 50 numbers are there, 1 to 50. So pick one by one until you satisfy the required number. Well, first time when we pick, how many are there inside the box? 50. Second time when we pick one, how many are there inside the box? 49. So one might argue like, are we providing equal chance? Actually, we do. We provide. Okay, I think we don't need to get into those. But believe me, that issue does not arise because in simple terms, I hope you can understand. Second time we will be picking is out of those who did not get picked in the first one. That's very important. The person who got selected cannot be selected again unless we replace them. If we are replacing every time, we have the same number so that equal chance is there, no problem. In each pick, equal chance is there. Each pick, equal chance is there. And then even if we do not replace, after reading the value, if we put that number also back into the box, mean what is called replacing it. So every time we have 50 in the box. But usually we don't do that. After reading that, we keep that aside. We don't put that back into the box. That's why second time when we pick a person, we have only 49 inside the box. So then only that question arises. One can argue, are we providing equal chance? Yes, we do. How come is that? Second time we are picking out of those who did not get picked in the first row. And thereby it can be shown we are providing equal chance. Right, okay. That's how we pick a random sample. Okay, drawing number, that is what is called drawing numbers. So if we have like say 7, 23, 26, 41, 11, like question we will have. So we'll go on picking one by one until we satisfy the required number. Suppose required number is 15. So you go on picking one by one until we satisfy the number 15. Right. And then suppose we have something like say the whole PGIA. Whole PGIA. Let's say like the time 2000 students. Let's say 2000 students. Then we need to write down numbers 1 to 2000. Will it be entertaining writing down numbers? Not at this stage, isn't it? You were in year 2, year 3, you would have enjoyed that, but not now. Okay, if it is 50, you might somehow manage, but 2000, you might find it to be like boring. Right? In such a case, something you can do is you can use something called random number table. Random number table. Where tables are available, in fact, any statistic book, last few pages you find tables. Maybe the very first table is this random number table. You find numbers are arranged like 5, 0, 1, 7, 8, 8, 6. Likewise, numbers are there. This is row, and then column wise also, say 9, 1, 8, 5. Likewise, you have numbers. And then row wise or the column wise, do you find any pattern? No pattern is there. So that these numbers appear in rows and columns randomly. No pattern is there. So that we can start from any point, and then as the way numbers appear, you start from any point and then read it row wise or column wise. And then as the way numbers appear, you pick numbers from the population. Now, population is now well identified. We have labeled them 1 to 2000. So that as the way we find numbers, you pick the appropriate student from that 2000. Right. This time thing is, now see, what is the first number? Suppose you start from this point, 5. Second one is 0. Let's say 5 is 5, 1 is 1, 2 is 2, 3 is 3, likewise 9 is 9, 0 is like 10. So 0 means 10th person, 5th person, 10th person, and then first person, likewise. Suppose we want 4 and 7. So these are the 4. Right. And then you find that you can have a number only between 1 and 10, including 1 and 10. You cannot have a number outside 10. Okay. So to include numbers outside 10 also, what you can do is when reading numbers, you can read 2 digits at a time. So that 50, second one is 17, third one is 88, likewise. So if it is 50 means 50th student, 17 means 17th student, 88 means 88th student, likewise. Suppose we have only 50 students, and then if we have a number like 88, there is no such student, you skip that number, go to the next number. Likewise, you carry on until we satisfy the required number. Is that clear? Thereby, we can have numbers. What? 01 is 1, 99 is 99, 00, let's take it as 100. So that time we can have a number between 1 and 100. Suppose we have in the class, like today, 170. So if we consider 2 digits at a time, then we can have numbers only between 1 to 100. So that the student having a number outside 100 cannot get selected into the sample. Isn't it? So that how many digits do we need to consider at a time? Then we need to consider 3 digits at a time. So in this case, 501 and then 788. Likewise, you go on reading. Whenever we have a number above 170, you just omit that number, go to the next number. any number less than 170 can be considered, and accordingly, you can pick the corresponding student. Okay. By the way, time is 4 past 10. It's like halfway through. Shall we have a break? I think it's good to have a break, isn't it? Now, and then meantime, just now also I received a message from the PGIA system analysis saying that still some have not included that number along with the name. So please attend to that. Now, the first day, maybe not very familiar with, so that could be the reason, or otherwise maybe they join little later. So those who have not included the number along with the name, please include that. Okay. If you have a registration number, include the registration number. Otherwise, you include your identity card number. Mind you, this is not just for today. This is for all the meetings that we have hereafter. Use the same number. Okay, so otherwise we will have a problem with especially quiz marks, taking quiz marks into account. Right, time to have a break. So let's have a break and start. And the break is for 15 minutes. So now it's 6 past. So we'll meet at 21 past 10. Shall we start since time is up?
Okay, sir.
Okay. We have now 158, there are about 175, so the others join. They may be still having their tea. So let's start. Hope by now everybody has included either the registration number or otherwise the NIC number in the name list. One. Still we have one name by Shakila. Shakila.
Yes, sir, I will rename.
Okay, thank you. Right, okay. We were talking about please check and see whether your mic is muted. If not, get them muted. Okay, right. We'll see. Time to time, I'm getting messages from the computer unit saying that some of you haven't included the number in that name list. Right, okay. So talking about different methods that can be used to pick random sample. In general, in case if it is selecting 1 out of 2, you can think of tossing a coin. But specifically when it comes to picking several out of a substantial number, you can go by drawing numbers. But if the number in the population is large, you find that to be not that practicable. In such a case, we can use random number table. With a random number table, depending on the number in the population, if it is a single digit number, then we can go by as it is, in the sense that when reading numbers from the random number table, we can read one digit at a time. If the number in the population is a 2-digit number, then we can consider 2 digits at a time when reading numbers from the table. If the number in the population is 3-digit number, then we need to consider 3 digits at a time. That's how you decide how to read numbers from the random number table. Now imagine the case we have something like 182 in the population. So that we need to consider 3 digits at a time. Then 0, 0, 1 is 1, and then say 1, 2, 5 is 125, and then 200. as the 200th. Right. Now, only 182 are there in the population. So that whenever you come across a number outside 182, what do you have to do? Skip that number, go to the next number. Isn't it? So that we can see only the numbers starting from 1 up to 182 can be considered. Rest cannot be considered. Every time you need to skip that. See, when you consider 3 digits at a time, you can have a number starting from 1 up to 999 followed by 000, which is 1000. 1000 possibilities are there. Out of them, you can consider only 182. Rest of the times, you need to skip that number. So that you will find most of the time you will be skipping numbers. That might also be a bit boring. So to avoid that, something you can do is 001 to 200 is equivalent to 201 to 400 and 401 to 600, 601 to 800, 801 to 000, which is 1000. So that imagine number that you pick is 25. 25. Which person are you talking about? 25th person. Suppose the number that you pick is 225. Okay. 1 is equal to 201. 1 is equal to 201. 200 is equal to 400. So similarly, 25, 25 is equivalent to 225. Similarly, it is equivalent to 425. Similarly, it is equivalent to 625. Similarly, it is equivalent to 825. So that if the number is 25, 225, 425, 625 or 825, the person that you select is 25th person. Otherwise, 150, 350, 550, 750, 950, you will be picking 150th person. So that you will see, we don't have to ignore numbers most of the time. You can consider that. So you can easily complete picking sample. Okay. Please keep the mics muted. Sahan, I see that you have not included your number. Sahan, can you attend to that?
Yes.
Right. Right. So thereby we can make reading numbers to be picking the sample to be a bit more efficient. So that's about the third method. Fourth method is using computers. Using computers. Right. With the use of computers, statistical software, all what you have to do is to specify number in the population, usually denoted by capital N. Number in the population. So earlier I said 182. and then number of units you want in the sample. Let's say 25. That's all you need to specify. And of course, computer will ask you with replacement or without replacement. So that you can specify with replacement or without replacement. With replacement in sense that it's possible, same number you will have over and over again, theoretically. Without replacement, it's not possible. With replacement also, if large number of values are there in the population, chance of having the same number again is very difficult, isn't it? It's same as without replacement. And then obviously having the same number over and over again is not that interesting, isn't it? Because what is expected is that to give representation of the population. So having the same one, we cannot capture the variability, isn't it? Because the whole issue is why are we having several? Because values are different. By having the same person over and over again, we cannot have that information, isn't it? We want to capture the variability. So that very often what we practice is without replacement. Okay, but both approaches are there. And then as I said that if the number is that large, you will find it to be, doesn't make that much of a difference. Right, so those are the procedures that can be used. Well, imagine we pick same example of studying height. Suppose we pick 25 within a class of how many did I say? Okay, our group 175 or 180. Now, suppose I pick 25. How did I pick? Randomly. Why randomly? Then only I can have an unbiased estimate. Remember? Unbiased estimate. With an unbiased estimate, one might think of what is expected is that our estimate will be close to the true value. In fact, the difference between estimated value and then the true value, the parameter value, is called sampling error. It's called sampling error. But doesn't mean there's something wrong. No, but that difference is because what we are targeting is the population parameter. But we know we can never have that value. So the difference is termed sampling error. Right. Once you have such a value estimate, what is expected is that difference to be small, isn't it? What is our target? True value. Our target is true value. Now one can argue if the target is true value and if we cannot have the true value, what is the use of the estimate? What we are aiming at is a true value. And what we are telling now is that by means of sample, we will never ever have the true value. So one might ask the question, then what is the use of the sample? What is the use of the estimate? In fact, good old days, this was an issue. In fact, that is the reason we have something called census. What do you mean by census? Studying the whole population, isn't it? These days, I suppose it is going on. Some of you have already provided the information. Others, there will be a person to talk to you very soon from Department of Census and Statistics. Hope everybody is aware of that. So, in general, everywhere in the world, every country in the world, they practice this event at least once in 10 years. So once in a way, having that information is not a big deal. But the thing is that the reason behind that was that in our good old days, the administrators never relied on values coming from the sample, or otherwise they never believed in estimates. Argument was that estimate is always different from the parameter. But the thing is, imagine the case, we are having a party. Imagine the case, we are having a party. If it is a party, as you know, one of the most common items is cake. Suppose we have again about 50 is taking part in this party. So we want to have cake as one of the items. So the question now is that how much of cake to be bought, isn't it? So if we want the true value, what we have to do? We need to ask from each person how much of cake is required. Some people like a lot of cake, some people don't like cake at all, some people bit, likewise, isn't it? One person, 5 grams. Another person, maybe 25 grams. One other person might say that even 75 grams. Likewise, that's how you find. Varies, variable. Same. Variable. So if you know the true value, add all the values so that you will know how much is required. So suppose found that 1,380 or 1.386 kilograms is the total. .386 is the true value. Okay. Right, now what do? We need to buy cake. Now party, let's say some students, so that maybe organizers, one of the organizers need to go to a cake shop and then buy cake. Now the question, how much of cake to be bought? How much of cake to be bought? Now imagine that person went to the shop and then asked for 1.386 kilograms of cake. Imagine, can we buy exactly that amount? Cake, the shop person will say that, no, it's difficult to measure exactly that much, so that it's difficult for that person to buy cake from that place. Isn't it? That is what the answer is. Isn't it? I'm talking about real world situation. Possible they measure cakes up to the closest 250 grams. Closest 250 grams. So that after 1.250, next one is 1.5. Some might go even up to 100, but let's say this shop, 1,500. So after 1,250, 1,500. So what? No choice. 1,000, 1.5 kilograms. Is it? Now the amount of cake has to be bought is 1.5 kilograms. Now what is our true value? 1.386. Now how much are we going to buy? 1.5. See? Even after knowing the true value, can we go by that value? Go by that value. Now imagine from a sample, instead of talking to all 50, we talk to say like 10 students and then ask amount of cake that they want. And based on that, suppose we got an estimate. Based on the estimate, let's say we work out the total required to be 1.410 kilogram. 1.410 kilogram. True value is 1.386. But from the estimate, we worked out the total required is 1.410. Now, how much of cake are we going to buy? Still 1.5 kilograms. Still 1.5 kilograms, isn't it? So what's wrong with that estimated value? Absolutely nothing wrong, isn't it? Because even after knowing the true value, what we go for is 1.5. Now, by means of estimate also, what we will go for is 1.5. So that, do we always need the true value? No need. Now imagine, talking to all 50 and then getting the value and then found this true value. Ultimately, no use. See, amount of time is money. Cost. No need. It's wasting. See? So that sometime you find, even if it is feasible to study the whole population. Now I was talking about, remember one of the examples, it's like small pond. You want to study the fish in the pond, small pond. If we want, we can empty the pond and then find out all the fish. Get the measurement and put the fish back into the pond. That is studying the whole population. It's not that difficult because small pond. Even if it is possible, very often people study the population by means of sample. The challenge, or otherwise the argument against the sample is what? So-called the sampling error, isn't it? You can never have the true value. That was the argument. Isn't it? And now what I said is that even if it is possible to study the whole population, people don't do that. People just go by sample. Because no point wasting time. Value coming from the sample is good enough. But you need to be a bit careful. Imagine from the sample, we found the value to be 1 point, let's say 1.886 kilograms. Suppose it was this, then what we will go for is 2 kilograms. Actual requirement is this. Then you find that a lot of cake is wasted. A lot of cake is wasted. We don't want that to happen. Of course, we don't have that problem if we went by the true value. See, if we went by the true value, we don't have that problem. But the thing is, if we can have value like this, you don't want to waste your time, isn't it? You don't want to waste money. You don't waste resources. Sometimes you need sophisticated instruments. It's very difficult, it's very costly using. Sometimes you find that well, you cannot handle that many. So then just forget about that study. It comes to a level, either you study by means of a sample or otherwise forget about the study. Choice is what? Only way out is studying by means of a sample. So the point is, what we are aiming at is having a value where you don't find it to be a waste at the end. You don't find it to be a waste at the end. Maybe one more example. Suppose actual drug dose required is 2 milligrams. And then estimate is found to be 10 milligrams. Now see, 10 milligram, 2 milligram. It's a very small amount. It's a milligram I'm talking about. Actual dose is 2 milligram. 10 milligram could be end of the patient. Could be end of the patient. 10 milligrams is a small amount, but possible end of the patient. Do we want that to happen? Oh, no, no way. Actual value is 2. How about 2.1 milligram? I suppose that would be okay. So that with any value that we are aiming at, there is certain error that can be tolerated. There's certain error that can be tolerated. So our target should be to have the estimate, within the tolerable error. Within the tolerable error. That's our target. Okay. So when we have an our estimate, then we need to make sure that our estimate is within the tolerable error. Isn't it? What I said is that as long as we have our estimate within our tolerable error, that estimate is good enough. If we find it to be like outside the tolerable error, no use. So that when we have an estimate, we need to make sure that it is within the tolerable error. How do you know it is within tolerable error? Let's say we know what the tolerable error is. When it comes to cake, you might take it as tolerable error is 250 grams. Let's say. Or otherwise, maybe 150 grams. Likewise, let's say, well, according to if they measure only up to the 250, let's say maximum we thought is 250. Likewise, the drug dose also, we can decide what the tolerable error is. So when we have an estimate, what we need to make sure is that whether it is within the tolerable error. So first thing is that we need to know how much of an error is there. How do you know the error? Error is the difference between estimate and then the true value. Let's say parameter, or if you want, let's say true value. This difference. So from the sample, we get the estimate, and then in order to know how good this estimate is, you need to compare that with the true value. Thereby only we can know how close this estimated value to the true value, or otherwise how much of a difference is there. But the thing is, do we know the true value? Do we know the true value? No, we don't. In fact, if we know the true value, is there anything to study? What is there to say if we know the true value? If we don't know the true value, only we need to study that by means of a sample. This is interesting. This is In a way, it's very funny, isn't it? See, what I said is that when we have an estimate, we will find that estimate to be useless if we cannot find that estimate to be within tolerable error. So in order to know whether our estimate is within the tolerable error, we need to know how much of a difference is there between our estimated value and the true value. So in order to know that difference, we need to know the true value. Well, isn't that funny? Why are we trying to study? Why did we think of taking a sample? Because we want to know a value in the population. Since we cannot study the whole population to know that the value, well, the only choice is studying it by means of a sample. Now what are we telling? After having the sample, after getting the estimate, we need to know how good our estimate is. And in order to know that, what we are telling now is that we need to compare with the true value. If we know the true value, there is no need of this study. We can go by the true value. Now we have a dilemma. Isn't it? Well, once we have an estimate, I suppose we have a very fair question of how good our estimate is, isn't it? Because otherwise, now, just before this, I said that, time it's possible, we find our estimate to be useless. And going by that, we are wasting our money, time, resources, everything. So that once we have an estimate, obviously, we need to know how good that our estimate is. The question now is that, how do we do that? Because we don't know the true value. The approach of answering to that question. Now, I think everybody is curious in how to handle this, isn't it? Very fair question. We didn't answer that question. How do we answer that question? We don't know the true value. The way we answer that question is using the approach called chance of having this difference estimate and the true value. Chance of having this difference to be greater than some predetermined value. Predetermined value. Now, remember we said that tolerable error, that we can always decide. Researcher can decide that. Predetermined value. Okay. If this chance, if the chance of having this difference to be greater than some predetermined value is high, chance is high, what can you say about this estimate? Good or bad? If the chance is high, what we want is this difference to be less than this. Greater than that, this chance is high in sense that very often we get this difference to be greater than k. Chance is high mean very often we will get this difference to be greater than k. So that estimate is a poor estimate. If the chance is low, then it is a good estimate. Okay. That's how we tackle the situation. In fact, we can study the sample. Probably we don't need to get into that detail because we have a specific objective with course. Now, if we get into sampling, in fact, you can see there are complete separate courses offered in statistics by the name sampling. You can have separate course just one complete course on sampling. There, you know, you can study those things in detail. In fact, PGIA, we have a very flexible administrative system. From any board of study, you can, in general, can follow a course from any MSc program. That possibility is there. But the thing is that each board has identified certain set of courses, and from those courses, you need to satisfy the requirements. But following any other course is up to the student. So that if you find a course offered in another MSc program, but you find it to be interesting, you have the possibility of, you can always follow that course. We have that kind of a flexible strategy in the PGIA. See, we have provided all that to students, so that from your friends, if you come to know that, you know, now especially, now you have enrolled for probably food science or crop science, or likewise for different programs. Thing is that you might find, you know, a certain specific statistic course, let's say sampling course. Especially those who are studying probably sociology or something, you know. And then you might be interested in very often studying, but conducting surveys. See, you need to know how to do the sampling. See? Likewise, I mean, not only from Board of Study Statistics, but likewise, you know, you might find courses to be some, but 1 or 2 courses, you know, offered in some other Board of Study to be interesting. You have that possibility. It's possible. So be aware of that. Right. So the approach of answering that question is this: you can assess actually the chance. With the chance, you can decide whether the estimate to be high or large. In fact, when it comes to deciding the sample size, is very interesting topic. Sample size. Believe me, approach is what? First, you decide this tolerable error. Tolerable error. In order to have the estimate within that tolerable error, you can decide the sample size. Using this approach of chance of having the value outside there. You can control this chance. You can control this chance by having a different sample size. That's the principle. This chance, having the chance to decrease this chance, what is given on the screen, can be decreased by increasing sample size. So that is the principle. So thereby you can decide what sample size to be used, so that according to that sample size, it is assured that we will have our estimate within that tolerable error. Not only that, we need to make sure the correct approach of picking the sample. Right. Back to the same example of studying height. Suppose out of 50 students, oh, okay, sorry, 175. 175, let's say I pick a sample of 25. Imagine the whole sample consists of females. The whole sample consists of females. I pick completely randomly, not purposely. Not purposely. Now I have the list. Remember, we discussed the method. Okay. Discuss the method. So pick the sample randomly, 25 randomly. But sample, imagine sample just happened to consist of only females. What kind of estimate will we have? Of course, this time it is unbiased. But even if it is unbiased, you find you find the estimate to be what? Underestimate to otherwise and overestimate. When it comes to height, in general, females are not as tall as males. In general, sometimes you find some females to be taller than a general male. Okay, but say in general. So that if the sample happen to consist of only females, we will end up with what? An underestimate. Other way around, happen to consist of only males, it will be an overestimate. So now you can see overestimate and underestimate, what is meant by is that big difference between true value and estimated value. Even if the estimate is unbiased. By the way, I went by unbiased is that, what I said is that, but manipulated. But random sample in sense that they said that anybody can be in the sample, but everybody cannot be in the sample. Okay, anybody can be in the sample. Well, when adopting that method, the sampler or otherwise the researcher should not know, well, until end of the study, until completing the sample, the researcher should not know who will be in sample. If the researcher knows in advance a specific person will be in sample, mean estimate is biased. Okay. That's how we have. Well, tolerable, I think I understand the question in the sense that, well, tolerable error is decided by the researcher. Maybe with the support of the literature, or otherwise talking to another researchers. Likewise, researcher should decide that. Okay, right. So back to the point of this biased and unbiased in sense that until the researcher completes the sample, the researcher should not know who will be in sample. Right. But even if the estimate is unbiased, it's possible estimate is highly deviated from the true value. Estimate is highly deviated from the true value. Case like this, now you see sample happen to consist of only females. Compared to the true value, where we have both males and females, if the sample happen to consist of only females, you will find a big difference between the estimated value and the true value. And with males also exactly the same, but other way around. So that you can see naturally, in order to have a good estimate, this is very obvious, straight away, common sense, need to make sure both males and females are there in the sample, isn't it? We need to make sure both males and females are there in the sample. And then, now, if you think of a real world situation, suppose you undertook an important study. The finding is so useful. If that is the case, you find that such information appears, suppose it is related to day-to-day life, and you can find that in the finding appears in the headlines of the newspapers. See, some value is 200. Just imagine. And then possible, it makes a kind of a revolution in the country. So important, it's appearing in the headlines. Let's say the following day, one more person has completed similar study, and that person has come out with a value to be 50. Your value is 200, that person's value is 50. Now the country is in big trouble, isn't it? Suppose that since the value is so important that 50 also appeared in the newspapers. Because it is so important. Oh, there is a big problem, isn't it? One person has said it is 200, the other person is telling it's only 50. One person said 200, the other person said 205, 210, 195. Not a problem. Not a problem at all. As the way we also discussed, we know sample to sample estimate varies. We are not talking about the same set. We are not talking about the same sample, it's different sample. That anybody can understand. Any person can understand that. But when one person says 200, the other person says 50, the way people will take it as one person is definitely wrong. But do you want to be the one who is having the wrong value? No, we want always the other person to be wrong, isn't it? Not that my value to be wrong, but other person's value to be wrong. You want other person to be wrong, but not you. Isn't it? Natural. But the thing is that not only thinking, but do the work also in such a way, chance of making a mistake is very, very less. Right. When you have estimate, now you see earlier also I said that your value is 200, other person's value is 195, not a problem. Not a problem. Anybody can understand that. Okay. Meaning, when we have two estimates, we don't expect the difference between two estimates to be large. Estimate to estimate, we don't expect that much of a difference. In other words, what we expect is that these estimates to be kind of repeated in every sample. Not that much of a difference in that. It is like same value is appearing over and over again. That is what is expected. So that you can see, we don't have a situation like one is 50, other one is 200. Okay. That is what is called. That is what is called precise estimates. Precise estimates. These are less variability. Less variability. Estimates, mind you, estimates, not the observations. Estimates we are talking about. Precise estimates. Okay, this is what we want. Right. Now, back to the case that sample happened to consist of only females. Obviously, you find that the big difference. And then other way around, only males also big difference. But if we have both males and females, you can see that the sample is which can be called as more representative, so that estimate will be definitely closer to the true value. Okay. So you want good estimate, otherwise more representative, better representative sample. See, now with the previous approach, by preparing a list and then picking a sample, we had all the numbers inside that box. Inside that box. We considered all the numbers and pick a sample. Random. Such a sample is called simple random. Such a procedure is called simple random sampling. Such a sample is called simple random sample. Simple. Since that you consider the whole population together in picking the sample. In fact, with this method, every time you will have an unbiased estimate. But not necessarily it means estimate is very close to the true value. In fact, there is an exact mathematical definition for unbiasedness. I don't think we need to get into that right now. Maybe if we come across situation, we will talk about that, but I think that is not necessary for the moment. Okay. So there is an exact mathematical definition for unbiasedness. Okay. But we were going by in the day-to-day sense bias. Whenever manipulation is there, favoration is there, interference is there, obviously you cannot have the target value. That is what is called bias. That is how we went by. But remember, there is a specific mathematical definition. Those who study, those who follow the STAT program, definitely will get into know those things in the sampling course. There's a separate course called sampling, so in that you will get exposed to all those. But anyway, right? Okay. So simple random sampling. Every time you have an unbiased estimate, you can see that mathematical condition is satisfied. But the thing is, doesn't mean that we can have a good estimate. Now we are talking about it's possible with simple random sampling, the sample happen to consist of only males. Okay. Although unbiased, you can see that there's a big difference between estimated and then the true value. Right. So in order to have representative sample, we need to make sure both males and then females in the sample. So how do we make sure both males and females are there in the sample while picking the sample randomly? Obviously, with simple random sampling, there is no guarantee we will have both males and females in sample. Not only both males and females. Naturally representative in the sense that if more females are there in the population, obviously we have to have more females in the sample too. If less males are there in the sample or less males in the population, we need to have less males in the sample too, relatively. That is what is called representative. You cannot have it other way around. So not only just males and females. Okay. But we need to have proper representation. Okay. So first of all, how do we make sure both males and females are there in sample? That can be assured if we first divide population into males and females. You see, now we have two layers. Or otherwise in statistical jargon, we call them to be strata. Singular is stratum. Stratum is singular, strata is plural. We divide the population into strata and then apply randomization to each stratum. Okay. So that we can see the method that we are adopting is different from the method that we discuss here. Simple random sampling. Here is not simple random sampling anymore. If it is simple random sampling, we need to consider the whole population together. But now we are not considering the whole population together. We are considering both males and females separately. Okay. Such an approach is called stratified random sampling. Stratified random sampling. Okay. So it is guaranteed. You apply randomization to male group, pick some. Apply randomization to second group, pick some. Apply randomization is like you are applying simple random sampling to each group separately. Okay. So from male side, you will pick some males. From female side, you will pick some females. Mix them. We have both male and females. And then if more females are there in the population, then you can have larger number of females and then fewer number of males. So that also can be decided. And then accordingly, you can pick that number randomly. Okay. Randomization has to be there. Thereby only we assure what? Unbiasedness. Right. Think of a case we want to select set of patients. Sample of patients. So as the way we discussed, first thing is what? We need list of patients. List of patients. In fact, list of units in the population is called sampling frame. Sampling frame. So that if you want to pick a random sample, whether it is simple random sampling or the stratified random sampling, what is the primary requirement? Sampling frame. You need to have list of units. Otherwise, you can't pick a random sample. Okay. But imagine a case study, imagine a case or a study such as you want to pick a sample of patients. Now, as the way we discuss, first thing we need is what? List of patients. Can we ever think of list of patients? How can you think of list of patients? Today you find a person to be a patient, and then following day you find that person is not a patient anymore. Patient is not a fixed phenomenon. It is not a fixed phenomenon. Maybe farmer, or otherwise doctor, could be a fixed phenomenon, at least into a certain extent. But the thing is that people change their employments then. People change their employment. You cannot, restrict employment of person from the birth or otherwise from the education or something. It's open to each person. But let's say profession, at least in a certain extent, we find it to be fixed. But a situation like patient is not possible. So the question now is that how do we pick random sample? Well, there you simply cannot think of list sampling frame. In fact, even if a list is possible, like suppose you want to study farmers, you might prepare a list or you might find a list, but the problem is that you cannot find a complete list or updated list. Sometimes you pick a person from a list, and then when you visit the person says that person is not a farmer anymore, used to be a farmer. So those problems are there, those challenges are there. Okay, so even if a list is possible, the thing is very difficult to have the complete table. It's a complete list. Now, mind you, as we discussed, if one person is out of that list, estimate is what? Bias, isn't it? Because the definition is what? Every unit has an equal chance. If one person is excluded, how can that person be selected? Systematic bias. Those are the issues. Okay. Right. Sometimes you can't even think of a list. Say list of patients. And similarly, imagine you are studying something like pollution in a river. Pollution in a river. What do you mean by random sample? I'm talking about one river, let's say Mahavali River, from Gampala to Katukastaka. You want to study the level of pollution. But just one river. What do you mean by units? When you say farmers, each farmer is a unit. Each farmer is a separate unit. But when it comes to river, do you find units in the river? No. All what you find is a flow of water. That's all. So what do you mean by picking a random sample? You need to have a different approach. Isn't it? Similarly, sampling in a forest. Sampling in a forest. You just have one forest. Can you take each plant as a separate unit? Oh, how come sometimes you find very small plant and sometimes you find a huge tree? And are you going to consider each of them as like separate unit? No, it doesn't make sense. Otherwise, within the forest, you don't find any established units like farmers, patients. Each person is a separate unit. That is very established, very clear, well defined. An electric bulb, no problem. One bulb is one unit, no problem. That's very clear, isn't it? And then office, one file is one unit. That's well defined. But when it comes to sampling in a river, there is no such a situation. Right? How do you do? This is where we need to think of alternative approaches, such as, very briefly, systematic sampling. And another such method is cluster sampling. Systematic sampling is that systematically, like every quarter kilometer, you pick a water sample. You travel along the river. Every 250 meters, you pick a water sample. And then from the other one also, water sample. For other 250 also, water sample like this. So that at the end, you will have, it's like maybe 25, 30 water samples. So you have 30 values. That is your sample. Secondly, forest also, forest, one might think of, let's say this is the map of the forest. You might think of dividing this into grids. Pick some grids and then consider each of these as a unit. That's possible. But the thing is, in a forest, those who have been to a place like Singaraj Forest knows that, or know that you cannot go anywhere that you want, isn't it? You need to go with a person, and if you say that you want to go to a particular place, you will say, no, forget about that. You can't reach there. All what we can do is that within the forest, you find footpaths. Along those paths only you can travel. So what you can do is you travel 250 meters and then study a strip. Likewise, that's how you can do it. Okay. Likewise, coming back to patients, where do you find patients? If you go to hospital, you'll find patients. And if you visit a clinic, you can see long queues of patients. Maybe you can think of every 10th person in the queue. This is the queue. Every 10th person you pick into sample. Is that clear? That is what is called, what is every 10. That is what is called systematic. Systematically we are picking. Then it's like something against random, isn't it? We are talking about systematic, which is opposite to random. Right. In order to make this random, by the way, argument is that, do you know which person is coming as a 10%? Sorry, now within the first 10, suppose let's say 5th person. You pick every 5th person in the slots of 10. Within the first 10, you pick the first 10, you pick the 5th person. After that, every 10th. Likewise. Okay. And do we have any idea which person is coming as the 5th person in the first 10? No. That's random. We have no idea. But one can argue, suppose 2 patients came from the same area. Suppose both, after coming to know that the study is taking place, suppose they thought of joining the study, so that those 2 can get together and say that, okay, I will join the queue as a 5th person, you join the queue as a 15th person, so that we both can get selected into the sample. Is that interesting? That's possible, isn't it? Not impossible. So to avoid that, something we can do is within the first 10, you pick one randomly. Maybe the second one, maybe the 5th one, maybe the 7th one, like you pick one randomly. From that point onward, every 10th. Likewise. Okay. Thereby we can make the whole sample to be random. Well, that's one approach. By the way, I think I need to get back to the screen. Right, deciding, see, every 10, within the first 10, I said, picking one randomly. That's what I said, picking one randomly, and then every 10. Right. Why every 10? That you can decide based on how many are there altogether, in general, capital N, and then how many you want. Thereby you can decide N. Now let's say not many patients you find for the disease that you are interested in studying. So that you can think of, well, every patient in the queue to be selected. There is also unbiased, isn't it? No, see, everybody. Suppose I say that 10 students are there in the class. I am going to take all 10 students to Nuwara to help me in the study. Am I favoring a person? No, I'm not favoring a person. But if I select 3 or 4 purposely and then taking them to help me is kind of favoration. Exactly. So taking everybody is unbiased. So likewise, you can have all the patients if you don't find adequate number. But if you have more than what is adequate, then you can pick them like maybe every 3rd person, every 5th person, every 10th person. Likewise, that can be decided depending on the availability of patients. Okay. So the river one also depending on the length of the river, number of samples that you are expecting, then you can decide the distance to travel for a sample. Whether it is 250 meters or 100 meters or half a kilometer, likewise, that we can decide. Forest also exactly the same. Okay. Other one I said is cluster. Cluster. What do you mean by cluster? Cluster means several together, isn't it? Several together. That is what is called cluster. Instead of picking one at a time, you pick several together. Imagine you are undertaking a study in Colombo City survey. Right? Suppose you want something like 600 households. You want to study 600 households. Suppose food consumption. So, you want to prepare a product, and then you thought of studying people's kind of choice, something like that. Anyway, you just survey and say you want 600. Suppose you found a list. From a list, these days, if you find telephone directory, more or less everybody's name is there. Isn't it? So let's say you have the complete list, so you can pick 600 randomly from list of maybe, let's say 500,000. From 500,000, you can pick 600. Then you will find one person is from Paliyagoda, other person is at Vallavatta, likewise. So you talk to this person, and then now you need to reach Vallavatta. You get into a bus and then go to Vallavatta. How long will it take? Easily you will find about 2 hours. Yeah. Now you will see that you can study only about 2 per day. By the time you complete 2, you have no time to go to the next place. You got another 2 hours. So to complete the study, you need how many days? 300 days, almost like 1 year, without any holidays. 1 year. Maybe 1 year, what you are studying is so dynamic. Well, it's no point having such a sample, isn't it? If it takes 1 year to take the sample. Isn't it? Now, you need to have more efficient method. One possibility is that, say you have a map of Colombo, you divide this into grids, and you can pick some grids randomly. Maybe, let's say, you pick 30 grids. And then from each selected grid, you pick 20. And thereby you also you have 600. Now, when you visit one place, one grid, you can easily complete that 20. Easily complete that 20. So that within 30 days, 1 month, you can complete the study. See? Now, if you want to employ a person, in the first case, you need to employ that person for 1 year. Second case, you want to employ the person only for 1 month. Isn't it? Need to employ the person only for 1 month. You complete the study in 1 month. So cost-wise, you can see that it's much more efficient, the second one. Second one, now you see 20 is coming together. 20 is coming together from one place. That is what is called cluster sample. You pick the sample by means of clusters. Okay. But within that grid, obviously, you will find, we are talking about map and then Colombo. So one grid, you will find many more than 20. But what you want is only 20. What you do is, you pick a point randomly, you go around that point. You don't need to pick people from here and there. You don't need to prepare a list or something. You go around that point until you satisfy the required number 20. That's how you implement it. This is what is called cluster sampling. Similarly, let's say from school setup. You want to pick, say, 200 or 300. Where school consists of 5,000 students. You want to pick 300. In fact, if you talk to the principal, you can get the register of whole 5,000 and then you can pick 300. That's possible, not impossible. Instead, what you can do is, you can pick, now classrooms are there in the school. Isn't it? You can pick, let's say, 10 classrooms. 10 classrooms. And then from each class, let's say about 30 students are there. You select all the students in each class. So 30 to 10 is 300. So in the second case, you need to visit only 10 classrooms. Otherwise, for 300, you might be visiting something like 200 classrooms, 150, 100 classrooms at least, isn't it? See, second one is much more efficient. And interestingly, suppose you have selected a person, you go to the class, that person is not there. Very often you don't find students inside the class. See? So, see, that problem can completely be avoided by picking a classroom. Classroom, well, some students are there. Not that everybody is busy. Since we have not picked students, but we have picked classes, to be not biased. You see, the selected person is, well, identified person is not selected in the sense that it is biased. Now, that problem is minimized when you pick a classroom. Right. So, from the class, you pick the whole set. So, that is what is called cluster sampling, one group. Right. And the previous example, the city example, and then the school example, the difference is that second example, clusters are fixed. One classroom is one cluster. But in the first one, those grids were not fixed. We established those grids. And then the grid, you find the number much more than we want. So you see, sometimes you find clusters to be fixed, sometimes you find clusters to be not fixed. Okay, right. And one more thing, from one cluster to the other, one classroom, within one class, you find students of same age, likewise, same subjects studying. So you don't find that much of a difference. Similarly, that city example also, same area, maybe same interest, isn't it? Sometimes you find the whole area, Colombo 7 mean same interest. And then maybe some other area living in flats, well, more or less same interest. So you don't find that much of a difference within a cluster. So that capturing variability, you do by means of different clusters, not just one cluster, different cluster. One place to the other, you find difference. That's how you try to capture the variability. Well, now if you compare, earlier I said that if from the list also, if you want, you can pick 600. Now by means of clusters. Now if you compare the two, definitely second approach is cost-wise very effective. But in terms of precision, you see, if you pick one by one, the simple random sampling, then by means of each person, we try to capture the variability. Isn't it? Because each person is like different. So that in terms of precision, you find first approach or the picking each person randomly is better. So now, precision wise, first method is better, cost wise, second method is better. isn't it? Now the question is which one to be selected, which method to be adapted. Thing is, cost plays an important role. Usually, if we don't find that much of an increase in precision in the first method, that much of an increase in the precision, then no point going for that method. Usually, if at least 20% increase in the precision, if at least 20% increase in the precision is not there, no point going for the costly one. If high precision is achieved, it's worth going for the more costly one. If the increase in precision not that much, then no point go for the more costly one. Very often you find that we use the second approach. Because I said that, see, it takes long time is also an issue. Isn't it? Or otherwise, you will have to employ larger number of enumerators and then undertake the study. So it's more costly, but cluster-wise is definitely less costly. Okay. The thing is that if you don't have money, if the allocation of money in the grant for sampling is less, then you may not be able to implement the first method. You will have to rely on completing the second method. Okay. Right. So now we have gone through 4 different methods in data collection procedures. So those are called kind of sampling techniques. Okay, so those are the methods, and see, depending on the situation, I suppose you got a good exposure to the data collection procedures, because at the end in your MSc program, I think everybody has to undertake a study called directed study, or otherwise sometime 1 year research. There you will find this to be very important, how to pick the sample, data collection. Okay, so keep this in mind, and along with this line, you can think of picking the sample. By the way, remember I was telling that time to time we need to have an assessment. Shall we have a go today? Try the first quiz, or are you all ready? Thing is that you need to have the camera on. Make sure that everybody is properly dressed, so everybody can see the other person. Is everybody ready, or? No, I thought of having. Oh, okay. What is this? Huh? You mean no need? Okay. Right. Then we will have the formal one starting from next week, but without making the camera on, shall we have a trial and then see that how it goes, sending it and like that. So this one will not be taken for the assessment. Can everybody get ready? No need to have the camera on today, but starting from next week, everybody should have the camera on. Okay, we have an understanding. Yeah. Okay, so let's have it that way. But remember, starting from next week, it will be the case. So can everybody get ready?
Yes.
Okay. Right.
Yes, sir.
Right.
Yes, sir.
Yes, sir.
Yes, sir.
Check and see whether your mic is mute. If not, make it mute. Right. So today's trial quiz. Okay. Trial quiz to get an understanding so that you will know what a quiz means, at least for this course. Then how to deal with that. No, it's not a big deal at all. Okay. Right. Now, hope everybody's ready. And let me now write the question on the screen. Maybe before giving the question, let's start with the simple one anyway. Well, what I am expecting is kind of intuitive answers, logical answers. You may not be able to give kind of an exact answer. Answer is exact, but in the sense that not like 5, 2.3. Likewise, you may not be able to give the answer. Okay. Kind of a logical answer I'm expecting, intuitive answer. So keep that in mind. Okay. Just question yourself, then you will get the answer. Is that clear? So that is a kind of answer that I'm expecting. You will see that, I mean, in the notes, you will not get the exact answer. Question is not, now I'm asking, for instance, list the sampling procedures, at least list 3 sampling procedures. No, that is not a question at master's level, isn't it? That is not a kind of answers I'm expecting. Okay, so that you will not find the exact answer from the notes, but what we discuss, or otherwise, it's based on what we discuss. It's based on the notes, but you don't find the answer directly from the notes. Okay, right. Question is, right, I think those who join later, at the beginning, I informed how to do the answering. See, I told that I write down the question on the screen, and then all what you have to do is to type the answer in the chat box, and then through the chat, you just text it to me. Okay. Just through the chat. So right here, type message. I haven't given the question yet. Wait a minute. Okay. Still I'm describing the procedure, especially for those who join later. So just type the message here and then click on this, thereby I will get that. Okay. And then, of course, you can send it only to me, you can't send it to the others, and then check and see that you can send the message only to the host. Okay. Right. So let me now write the question. How many randomizations? Okay. Not how many I'm going to pick randomly. Okay. How many randomizations will we get in stratified random sample? Remember, we discussed how to do random sampling. Sorry, stratified sampling. We went through simple random sampling, stratified random sampling, And then other two procedures, systematic and then cluster sampling, bit briefly. My question now is, in stratified random sampling, how many randomizations do we have? Remember, we discussed that how do you do the randomization in stratified random sampling? We need to do the randomization for each stratum separately, isn't it? That's how we do. So that I think I have given the answer now. Since this is a trial one, I'm helping everybody. Right. Check and see. Check and send that now. Since now you can think of the answer very easily, let me know. Send me the answer. Time is 52. We started, I think, around, yeah. So we'll stop at 56. How many randomizations will we get in stratified random sampling? Only 2 more minutes. Well, the time is over now. Can I have it from everybody quickly? Can I close it now? Is it finish or? Um, right, looks like still sending. Of course, I had 175 is there. We had about 178, 180, but I think I received only about 130. Is that others are not around? Right, looks like all over. I'm going to now close it, save chat. So I think, yeah. Oops, still sending. Right. Well, at least from next week onward, please stick into 5 minutes because once I close, you won't be able to send it. Thing is that for this kind of a question, we cannot be spending half an hour because we have only 8 meetings. In that, we need to spend like, well, the almost all that 32 hours for the discussion, or otherwise for the lectures, not for the quizzes, you cannot be spending 15 minutes, 20 minutes likewise. So make sure that everybody finishes in 5 minutes. Right. Answer to the question. Now, if you can remember, that if you can recall, example, we said male and then female. And then apply randomization to male group, apply randomization female group. How many randomizations? 2 randomizations. Why 2? Because this time we have 2 strata. Because 2 strata. Suppose in some other case we have 3 strata. Then randomization to first one, randomization in the second one, randomization in third one. How many randomization? 3. Meaning, how many number is equal to equal to number of strata. Isn't it? Number of randomization, stratified random sampling is equal to number of strata. If 2 strata there, 2 randomization. If 3 strata there, 3 randomizations, likewise. Right. So today, anyway, it's a trial. So starting from next week, we will have the proper ones. So make sure that well, the camera is on. If the camera is not on, then I take it as those they are not around. I will remove them from the list. So for that day, no one can attend to lectures from that point onward. So keep that in mind. And then submit it within 5 minutes. And then camera, make sure that we can see you clearly. Okay. Get the cameras adjusted in such a way that I can see everybody. Okay. Any questions, clarifications from today's meeting? Yeah, will be, I think system, I suppose the link for the recording will be sent to you, not to the MIS, because some of you haven't registered yet. Unless you are registered, you cannot have access to MIS. So that they will email you the link, and it's good that to send this message, since that the recordings will be available for those who are present only. Don't think of fulfilling, gathering knowledge simply by going through the recording. No, that's not possible, and it takes long time, and another 4 hours. That's not possible. Don't do this. So that you need to attend, and if you think that you haven't understood something when you go through the notes, well, you need to pick notes. Okay. Take notes. Thing is, you might find sometimes maybe something is not clear, the link from one point to the other, then you can open the recording and then see that how it is explained, and thereby you can get the understanding. That is the whole objective. Otherwise, by not attending and then by going through the recording, if you think of studying, I don't think that will be effective. Okay. Right. So yeah, time is now, when it is afternoon, it will be starting from 2 o'clock. Okay. Time. Okay, yeah. Happen to be absent, yes, can't help sometime, but it's up to each person. You will find that definitely there is a link, because this is a continuation. What is important is that, as I said, I want to know, how much you understand of what is being discussed. That is important, picking it up. Then you see, you will develop that. It's important you developing that ability also. So it will not be based on the previous week, because it is kind of taken to be continuation of the lecture. Sometimes if a person happened to be absent for the previous, then it could be an issue, isn't it? Because of that, usually we have it based on that day's work. Right. Anything else? Hope everybody understood what we discussed today. Whenever, in case if you find something to be not clear, please let me know, so that I can explain it again. Okay. Since you have the other one, shall we then close it for the day? Sorry, not close it for the day, close it for the session. Okay, since no more questions, clarifications are there. So let me close it for the session, and then we will meet again next week, Saturday at 2 p.m. Okay, inform those who are absent also. Remember, I asked everybody to pass the message to those who have not enrolled. Yeah, anybody can join. Okay, I'm closing it now. Thank you, sir. Yeah, you're welcome.
Thank you, sir.
Yeah, you're
Thank
welcome.
you, sir.
Okay, you're welcome.
Thanks.
Thank you, sir.
Okay.
Thank you, sir.
Yeah, you're welcome.
Thank you, sir.
Okay.